Hello folks, here's the newly made video on the U.S. Drug Enforcement Agents. We actually did this in class, and I'm going to do it in this video so you can follow a bit more closely. So I've got the model set up, and if you read the directions, it sort of leaves it up to you what time frame you're going to be using for your simulation. Is it going to be months or years? We've told you that you should be running this over 50 years. But there's some parameters in the model that will need to be adjusted. And we've done this adjustment of these parameters. You folks are ISAT majors. We expect you to be comfortable with doing these types of conversions. So what I'm going to do is I'm going to keep it in months, and I'm going to run it for 50 years, which I'm going to start at 0, and this would be 600 months. And I think everything else will remain the same there. I'm going to go up to the top left-hand corner and click on the stock and drop it in here. Make it a little bit larger. I like having my variable names in the middle of my stocks. And at the bottom of the assignment, on a number of these, when they start to get a little bit more difficult, I've got a list of the stocks that are going to be in your model. So you're not going to have to identify the stocks in these later or in the later part of the assignment. So we have new agents in training. So this is going to be new agents in training. I'm going to go in and hit a return on this so it squares it up. And I know I have to have an inflow to this, and the instructions say that I have 1,000 agents entering. 1,000 new agents joined the ranks, and this is each year it recruits 1,000. So I'm going to have a flow in here, and I'm running this in months, so I'm going to have to divide the 1,000 agents by 12 months to get in the equal part coming in each month, right? So that's approximately 84, and I'm okay with rounding the numbers. But before I put that value in, I'm going to go, it says flow 1. I'm just going to write new recruits. And I'm going to round it to, it's 83.3. I'm going to round it to 83. And I put 83 in over here. You'll notice this is a rate. I cannot put units in the rate. It's automatically calculated by the software. So I'm going to go and double click on the new agents, and it says I'm starting out with 500 new agents. I'm going to go down, and you could call these agents, you could call them people, you could call them whatever you want. What you have to do is be consistent once you start labeling the units for these things. And they should be something that makes sense to you or to your client. So I'm going to call these agents. And the way you spell it, you want to make sure you spell it the same way every time. I spelt it with an S. I've got to do that continually. And so now I actually have a running model with all my correct units. You'd see there's no warnings down here on the right. So what I'm going to do, I'd like my stock sizes to all be the same. I could go down to this paintbrush, and it's 130 by 104. What I'm going to do is I'm just going to copy and paste, and I'm going to put my second stock in here. And you can see the gray area. If I slide my stocks over into that, I get more workspaces all. So, and now I'm going to put a flow between these two. And it doesn't tell you anything about how to label this, but it should be something that indicates the action that is occurring. And I'm going to label this becoming active agents. I'll square that up. And because I copied and pasted, I need to change the name in here, and I'm going for the stock has already been indicated, and it's agents on active duty. And I will square that up. And the one other thing, the new agents in training, they can actually drop out. So I have to have another flow coming out of here. And this is going to be, I'm going to call agents dropping out. PPING, sorry. Agents dropping out. I'll square that up, move it to the side. And I'm looking at the directions here. So it said they're staying in this stock for 12 months before they become active duty. So to simplify this, I'm going to put time in training. So I've clicked on a converter and brought it down. So anytime we're giving you numbers or anything in any of the assignments, or you're looking at the real world and there are parameters, they are going to be these converter variables is what it is. You're going to put that into your model. And this is where I'm going to put the 12 months. So time in training is going to be 12 months. I will double click and open this up. It's going to be 12, and I'm simulating in months, so this should be months. And we've talked about the proportional stuff. I'm going to click on my connector. And in order to calculate becoming active, I need information from the stock and from this time in training. So we'll click on that arrow again and go and connect it. And on the Mac, the last tool I've used up here, if I hold the command key down, or if I hold the option key down, it's the option key, I can drag and it will use the same tools I used before. So I'm going to connect that to here. So I have the information to do, and this is going to be a calculation. And all of the assignments in 4.5, the idea was to get you used to figuring out, are you multiplying or dividing? What type of equation are you sort of writing? Or math are you putting in? And if this is time, it's going to be division. It's going to be the stock divided by the time. So I'm going to click on New Agents, and it's going to be divided by the time in training. And if you think about it, it's hard to see here. It says agents per month, but this is new agents, which are agents divided by time in training. So that's why the units work out, and I'm done there. And it said that I think it's 2% of new agents wash out of training in the first 12 months, and I'm running this in months. So I'm just going to label this. I've gone up and clicked on the converter. Fraction washing out. And it said it was 2% per year. So I'm going to take that 2% and I am going to divide that by 12. I do not want to do it in my equation is what it is, okay? Please try to avoid doing that. I'm going to do it on a calculator, and it works out to be 0.0167 per month. And this is, you could label it a fraction or dimensionless. I like dimensionless because it pops up here, and I can click on dimensionless, and this is per month. And I've got this calculated, and now I can go and connect the fraction watching out. And again, I need information from the stock, new agents in training, going to its outflow. And imagine that. This is called a first order control. The stock is controlling directly without running through any other stocks the outflow. And because this is a fraction, I'm going to be multiplying, so the order doesn't matter. New agents times the fraction. And you can see all my units are correct, so I'm still in pretty good shape. I'm going to add injured and recovered agents. I'll just click on the stock and bring it down here. And this is going to be injured agents in recovery. Again, the stock name I gave you. I'd like these to be the same size. Instead of eyeballing it, I'm going to double click. I'm going to go down to my styles setting, which looks like a paintbrush. And if I recall, it was 130 and the height was 104. And it's about the same size as my other stocks. I can line that up a little bit better. Click on, square it up, and then I'm going to bring it down in. And so my active duty agents could become injured is what it is. So I'm going to connect a flow. And again, I like that using a verb in there, so it's going to be becoming injured. I'll square that up and move it to the side. And I know there's got to be something about who's becoming injured. And if I look at the instructions, every year 2% of agents are injured on the job. And this is going to be fraction getting injured. Square that up, and I'm going to go up to my connector, and that's going to go, I'll drag this over a little bit, and I know that the stock has to be connected to that outflow. It's typically the way it works, but not always. And, oh, I didn't go to my fraction getting injured was, the fraction getting injured is, every year about 2% of agents are injured on the job. So I'm going to do this on a monthly. The assumption is that it's going to be spread out. I've done the 2%, converting it into months before, so I know it's 0.0167. And again, I'm rounding. And I don't know. Going up 4-digit places is pretty precise. I think in the real world, we will not be getting data or should be depending on things that are this precise. I'm going to go down into my units, and again, this is the fraction per month, right? So I could call it fraction per month. I'm going to go with the dimensionless. I've already selected this, so I can click on it before because I have a variable with the same name in there, and I'm good. I'm going to double click on this, and because it's a fraction, I know that I'm going to multiply. This is just something you should start memorizing. And I will be asking this type of stuff on quizzes. I'm going to go into the injured agents. It's going to tell me that it's going to be 0. And you can see the agents are selected already. And the reason is because I've connected this stock to this stock. And it's sort of a conservation of mass. I can only move the same things between these stocks when they're physically connected with the flow. I'm not converting it into anything else. It remains agents in each stock. So the software is going in and it knows you've got a flow coming in. Conservation of mass is a real thing, and we are going to have the units all have to be the same in that case. My agents can recover, and I'm going to click on the injured stock and drag up with my flow, and I'm going to name this as recovering agents. Square that up, and I will move it. And when I look at the instructions, it says the agents are off duty for approximately 3 months. So I'm going to click on my converter, and this is going to be time to recover. And I've got this selected. I know it's going to be 3, and it's going to be months. And then recovering agents, I need to know how many agents are in that stock or in that pool who are out injured. Whoops. I'll click on that connector. And then I'm holding my option key down again, and I'm going, and so it's this information. Now it's time to recover. So you should know injured agents in recovery divided by the time to recover. And it's going to be in months again. And now I have the recovered agents. Now I'm going to let me add one more outflow to this. And this is going to be active duty retiring. And it said they were staying in here for 20 years. So I'm going to go up and click on my converter, and time until retirement. I'll square that up, and I'm going to have to use information from my stock going to the flow, and I'm going to hold that option key down again to get the connector, and it's going to be these two. And it said it was 20 years, so that would be 240 months because I'm simulating this in months. And then what's this equation going to be? This equation should be the stock divided by the adjustment time. And my units are all still working. So right now I'm going to highlight all this and lower it just a little bit because I'm going to put my corrupt. The last stock to put in here is going to be corrupt agents. And corrupt agents, yep. And I'm going to double click on this, and I'm going to come down, and I'm going to click on the styles. And it was 130, the width, and the height was 104. And I will square that up and drag it into my stock and then line it up. And there's a flow. I know active duty agents can become corrupt, and I'm just going to label this flow becoming corrupt. And I will hit return and move it. And now there's a fraction of these folks who are becoming corrupt. And it says every month 1/10 of 1%. Another calculation. So this is really a fraction becoming corrupt. And it's 1/10 of 1%, which should work out to be 0.001, right? So I'm going to double click on this, and it's 0.001. And this, again, is going to be dimensionless, or a fraction per month. And I'll go with dimensionless per month. And now I'm going to connect my agents to the stock, and it's the direction of the flow. It's where it's flowing from is connected in this case. And I'm going to click on my connector, and it's fraction becoming corrupt connecting. And because this is a fraction, what is the equation in here? And it's going to be agents on active duty times my fraction. I'm multiplying. I'm good. The number of corrupt agents, you can see it's agents again, same reason as before. It's going to be 0. And now these agents could retire, get caught, or killed. I think that was the 3, sort of a long variable name. And they only last 15 years when they're up in here is what it is. So average time until corrupt leave. And it's leave or gone. Again, you can name these pretty much any way you want. They need to make sense to you, and you should be able to tell a story about what's going on. And again, there's an outflow. My stock is connected directly to my outflow. I need that information to figure out how many are in here and what fraction of them are getting, or how long they're staying in here before they leave. And the average time I'm going to connect. And it said it was 15 years. So that should be 180 months if I'm doing my math right. Feel free to correct me if I goof. Months. And now the equation in here should be, because it's time, it should be corrupt agents, the stock, divided by that average time. And the other thing to think about this is when these agents are flowing into these different stocks, what we're assuming, and we're assuming this with system dynamics, that when something's in a stock, it's completely mixed is what it is. And so even when something flows in at first, a portion of that could be flowing out relatively quickly. The time until retirement is really an average time until retirement. So the average agent would be staying in there for 20 years. And that's sort of something, if you have questions, you should be asking me. I have a running model now, so I'm going to put a graph in. I'm going to click on the graph, and let's see. I'll put it here, and I'll slide this over and try to make this a bit larger. I can close this for now. Make this a bit larger. Still on my screen. And now I'm going to double click so it opens up. There's two ways of doing this. You can click the plus sign, and all the variables here will start show up. So I have, let me start with new agents and training. Okay, and then I'm going to go to my agents on active duty. I'll click on the plus again, agents on active duty. And then let me go with my injured agents in recovery. And last, I'm going to go with my corrupt agents. Click OK. So the agents, they're all the same units. So the y-axis here, it indicates what the units are very quickly. I want a name on this. I think all these graphs should have a title. So this is going to be I could just call it agents. I'm trying to think what's a good name. This should be, yeah, new and active agents. Even if they're corrupt, they're going to be active. And I am ready to simulate at this point. And I'm going to go down and hit the run button. And the scale is sort of off, so I'm going to double click on this and open the graph up. I'm going to go down to my graph indicator here. And I think the injured agents are not going to be a great number, so I'm going to put them on the right axis. The corrupt agents shouldn't be too high of a number. What I'm going to do to confirm that is I'm going to go and click on the variable, and I'm right-clicking, and it's going to open this window, and I'm going to go to View Results. So I'm going up to 2,000 people there. I'm going to close this. Let me look at my injured. I'm going to View and View Results. So they're going up to 500. I'm going to go to my new agents. I'm going to right-click and View Results. They're going up to 900. So I got the 500 and the 900 here. This is a couple of thousand. Active duty is going to be a big number. So I'm going to View Results. I'm going up to 10,000. So I'm trying to think, what should I put on the right and the left axis? So new agents in training, agents on active duty should be on the left axis. Injured and recovered should be on the right. I've done that already. Corrupt I'll leave on the left, and new agents in training I'll put on the right axis. And there we have our behavior over time graphs. And again, when you're looking at this type of stuff, if I end up changing this around, maybe the new agent shouldn't be on the right axis. Keep them so they're lower. And maybe, as I'm thinking of it, maybe I should keep everything so that it's on the left axis, and we will get the scale of this stuff. But this is what your graph would end up looking like. So this is what I'm concerned most about. If you make a mistake on a parameter that you're figuring out, I don't think that's such a big deal. You're going to get the same general type of behavior. And what we're really interested in is the behavior. And the behavior is coming from the structure. It's coming from the stocks and flows. We only have simple feedback loops in this. So it's the structure we're really interested in. And what I'm really checking is, does it run? Are your units correct? And does it relatively make sense? Like, you can't have, agents going negative, right? That's physically impossible. So I've looked at that type of stuff. And here's one last thing I'm going to do. When you simulate this, and I think the plus and minus signs are extremely important, but the simulation indicates, a red indicates it's a plus, and you can see it puts a plus on here, and there's a minus. There's a flow going back this way, right? Because it's sucking these people or agents out. It's pulling them out. So this represents a feedback loop, and the red is the positive connection, and the blue is going to be the negative connection. And over here what's happened, I think if I slide back, we'll start to see some colors. There, you can start to see how those feedback loops are mattering. And what's happened is, because we started out with 500, we can see these loops here, but what happens is once it gets into equilibrium, and it's flat, the inflows equal the outflows, so the rates of change are really, there's no rates of change. So the software is unable to calculate what loops are active because they're equal to each other. We'll flow to the right, and there we go. So this is how to build that model. Here are the big takeaways. That when you're looking at this, there are these first order controls. You should be asking, is there information coming from the stock to control? And in this case, it's all the outflows, right? The inflow is just a given in this case. When you're doing the population model, you're taking the families or the people between the ages, I think it's 20 and 45 or 21 and 46, who are the ones having the babies, right? So there's information to that, to a new inflow. So that can actually happen. But in this case, the stocks are connected to the outflows, and some of them are fractions and some of them are time. And you should know when it's a fraction, you're going to be multiplying in those rates. And when it's a time, you are going to be dividing. That's it for this video. Hopefully you find it helpful. You can follow this and submit this as part of the assignment. And thank you, and I'll see you folks in class.